Hi, this is Algebra 1B, Part 1, Unit 3, Polynomials and Factoring, Lesson 8, Factoring Special Cases. Okay, so this is learning to recognize when a trinomial or a binomial is the result of one of our special cases, either a perfect square or a difference of squares. Those are patterns that we've talked about already when it comes to multiplying. Now we're going to work them in reverse. The first thing that we need to conquer is making sure that we understand what squares are. Okay, so here are the list of squares. Squares are numbers that are multiplied by themselves. So 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. Okay, and that should cover it there. We do get into some of these teens as well in some of the problems, so that's why I listed it as far as I did. Okay, so let's look at the easy case first, the difference of squares. Okay, a difference of squares is really easy to recognize. It looks like this: a squared minus b squared. And it factors as a plus b times a minus b. Okay, so if you have a square minus a square, it can be factored as the square root plus the square root and the square root minus the square root. Let me demonstrate what that means. Okay. Let's take an example, a specific example. 49, color, 49, x squared minus 9 minus 9. If you look at your list, 49 is in the list, as well as 9. The square root of 49 is 7. The square root of 9 is 3. And so this factors as 7x plus 3. And times 7x minus 3. Okay, so just recognizing that when you have a difference of squares, it factors as the square root plus and the square root minus. Okay, another example. Let's say we've got 36x squared minus, let's do 25. Okay, 36 and 25 are in the list. 36 is 6 squared, 25 is 5 squared. So this is 6x plus 5 times 6x minus 5. And it's really that easy. It's as long as you have the difference of squares. Okay, now let's get into the more difficult case, and that's the perfect square. And by the way, all of this can be done by guess and check, right? Just like we've been doing with the other factoring. So if you do forget these special patterns, you can still do the problems by guess and check, by listing factors and trying them out. Okay, but it helps if you can have this shortcut. Here's the perfect square. The pattern for a perfect square is this: a squared plus 2ab plus b squared is a plus b squared. Okay, it's easier to recognize when you don't have a leading coefficient other than 1, right? And we'll look at some of those cases here. Okay, a squared plus 2ab plus b squared. So the first thing to notice is that it starts and ends with squares, right? So if it starts and ends with squares, there's a good chance this might be a perfect square. So let's do an example here. Let's do 121 x squared. And then on the end, I'm going to have 36. So 121 and 36 are perfect squares, are squares. 121 and 36, 6 squared and 11 squared. Plus, and let's see, 2 times 6 times 11. Oh, I picked a hard one. 2 times 6 is 12. 12 times 11, 120, and 12 is 132. 132x. Okay? But here's the pattern here. You can break it down to this. This is 11 squared, 11x quantity squared, plus, and then this is 6 squared, and we check the middle. The middle should be 2 times 11x times 6. And 2 times 6 is 12. 12 times 11 is 132. So it is. So it factors as 11x plus 6 quantity squared. Okay? So it's definitely a little more involved, particularly when you've got a leading coefficient. It's not so hard when your leading coefficient is 1. So let's look at this one. X squared plus let's do 10x plus 25. Okay? Again, 25 is one of our squares. It's 5 squared, right? And 1 is one of our squares. It's 1 squared. So we have 1x quantity squared. And we have 5 quantity squared. And in the middle I've got, do I have 2 times 5 times 1? X? Yeah, 2 times 5 is 10x, right? Or another way to look at it here, and I actually prefer this. Remember with our guess and check, we just did this. Remember we need factors of 25 that add to make 10. Well, 5 plus 5 is 10. 5 times 5 is 10. So this factors as x plus 5. X plus 5 quantity squared. Okay? And that's probably the way you're going to see it most, okay, with a leading coefficient of 1. So let's try another one. X squared, and I'm going to say plus 64. Now 64 is 8, right? I'm going to fill in the missing middle step. The middle piece is 64. 8 times 8 is 64, so we need 8 plus 8. 8 plus 8 is 16x. And that factors as x plus 8 quantity squared. Okay. Later on, this is going to become important for a process called completing the square. All right, so that's the difference of squares and the perfect square. I didn't label this. Perfect square. Perfect square. Okay, all right, and that's enough for today.